Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. Okay, this is part 2 of hazardous environments. We're looking at volcanic hazards. We're going to start off just talking about the general motion of tectonic plates. So this is the process of seafloor spreading. We have an idea that the seafloor is spreading because we have a magnetic polarity in the earth, and over time we can see and date the different rock as it's being created, as the ocean then is spreading apart. This is creating mid-ocean ridges. So let's explain this a bit further. We have then the concept that underneath the tectonic plate there is convection currents. There's heat coming from the core, moving through the mantle, and this then rises up less dense magma and rises it to the asthenosphere. In the asthenosphere then it's able to move more freely, and it starts to move along the bottom of the lithosphere, which is going to move in the same direction. The friction then within this is causing the motion. So the convection currents that are ongoing here are causing the plates to move in that direction. They'll then begin to cool down, being away from the source, and they'll begin to sink back down. And again, they'll be more dense but heated up again. So these convection currents are the reason why there are motions in the tectonic plates above them. So that motion of the tectonic plates then is going to sometimes open up a tectonic plate and cause it to split in the middle. This is on a constructive or divergent plate boundary. So divergent, like the plates are moving away from each other. We see that this is created by the convection currents first, and that's a good introduction there. So as you're explaining these things, it's good to have a few words about convection currents to be able to actually explain what they are. So we mentioned it there before, and this idea then starts to create what we call a rift valley. So this is where the plates are starting to separate, and then we start to see a hollow forming in that plate as it's being ripped apart. Now, right now, the East African Rift Valley is going through this exact same process, and then at the bottom we start to see things like lakes forming and that rift opening up. This will eventually start to get larger, and when it does, it will start to be replaced. So the continental plate, which is being split and dragged into two sections, is then replaced underneath. So magma is coming up, and then it's going to erupt here, and it's going to form new rock. This is going to form new igneous rock and start to form what we call an ocean basin. So a new ocean basin is being formed at the bottom, which we can see happening with the Red Sea as an example. So this is igneous rock. This is then going to be quite dense, hard rock. And we can see that it's going to be quite a lot lower than the continental plate, right? So the continental plate is quite large. This one then is quite narrow in comparison. We can also see this other area here where we see deposits sitting on top of the rock as well as it's expanding outwards. So this is the beginning of our divergent plate boundary from a rift valley to a new ocean basin. Then it becomes what we call a mid-ocean ridge. So the two plates are being pulled apart still by the convection currents, and as that happens, the new ocean basin then is widening out. This creates then a longer plate with igneous or volcanic rock with lots of sediment deposit on top of it. The new rock that's created in the mid-ocean ridge is then going to form a ridge that's quite large and just more prominent than the rest of the area. This is known as a mid-ocean ridge. The more well-known one around the world is the mid-Atlantic ridge. So we see the Eurasian and the American plate being dragged apart, creating a mid-ocean ridge in the Atlantic Ocean. So the idea is that if you were to look at, let's say, Canada and the UK, for example, and you were to reverse the timeline and go back in time, you would see that they would be moving back towards each other, because now they're actually every year moving further away from each other, with the seafloor spreading that is happening there due to convection currents. Now, while convection currents are the primary force or process that is causing this, ridge push also plays a role. Ridge push is a secondary process, and this is formed by the new elevated ridge in the mid-ocean ridge, and this is forming a push due to gravity downwards, which is also encouraging the motion of the plate in this direction. So it is that and the convection current that you can put down to as the processes that are moving it, the convection currents being the primary one. Okay, now we look at a destructive plate boundary. So with a destructive plate boundary, we have two tectonic plates colliding together, and also known, it's a type of collision plate boundary. So the idea here is that there's two plates coming together. Sorry, I should correct that and say this is a convergent. This one is a divergent, plates moving away from each other. This one is convergent, so plates moving towards each other. There's different types of convergent with plates moving towards each other. This one is a destructive plate boundary. This means that one plate is being destroyed while it's being built, while the other is potentially then changing. So we see then that the oceanic plate is going to be more dense. It's narrower, smaller, and it's going to be more dense. Therefore, it's going to sink under the larger, less dense continental plate as they're moving towards each other. This process is known as subduction. So subduction meaning that this oceanic plate is subducted under the continental plate. Now, this subduction then creates an area of friction where the two plates are colliding and one is moving under the other. This is known as the Benioff zone. This is the area where we can see intensive seismic activity. In this area here as well, we see a trench forming, an area where the continental plate is being pulled back slightly and the oceanic plate is being subducted. This creates some of the deepest areas in the world, including the Mariana Trench. Fold mountains are also a feature of a destructive plate boundary. This orogeny as fold mountains are forming is because we see a stop to the rapid motion of the continental crust moving forward, even though the convection currents are still working to cause this happening there. And due to that, then we would see that the continental plate suddenly gets a bit larger. This is because you have more continental plate that's pushing it behind, and you have less speed up front. This causes it then to rise up in height. So this creates what we call fold mountains. The Andes Mountain is a good example of this, as the Nazca plate is the one subducting under the South American plate here. So the continuation then of this happening. Now, what we also see then is the creation of volcanoes. Volcanoes are occurring because the top layer of the oceanic plate then, when it's being subducted and reaches into the mantle, starts to melt and give off then highly volatile volcanic material. This will rise up through the continental plate, build magma chambers inside the continental crust or plate, and will cause volcanoes to erupt. These are often happening all along these enormous plate boundaries. So because of that, the same process will be seen multiple times along the same mountain range. This is what is referred to as a volcanic arc. Here we can see an example of this with multiple volcanic craters in this picture here.